Okay, in this lesson we are going to look at applications of exponential functions, so word problems. So keep in mind that all exponential models are in the same form. They're all exactly the same. You take a starting amount, which is represented by A, and then you multiply that starting amount by a common ratio. And then you do that a certain number of times. So they're all the same. They might vary in the type of question, but they're all the same model. So you take a starting amount, you multiply it by a common ratio, and then you do that a certain number of times. If the common ratio, which we talked about earlier when we were graphing, if the common ratio is greater than 1, we know that it's going to be increasing, and we often refer to that as growth because it's getting bigger. If the common ratio is less than 1 but greater than 0, then we know it is decreasing, and sometimes we call that decay. So graphically, when I look at a graph that's going up, which is increasing, I know that's going to be growth. If it goes down, decreasing, I know it's going to be decay. So an example might be 2 to the x. 2 to the x would go up and would be growth. And then if I have a fraction base like 1/2, it's going to go down, which we would describe as decay. We can also identify, if you're given an equation, whether it's growth or decay, you're looking at the common ratio. So here the common ratio is 3. B is greater than 1, which indicates growth. Here again it's 3. Don't worry about the negative on the 2. So the 2 is the starting amount. So 3 is what we're looking at, the common ratio. It's greater than 1, so it's growth. In this bracket, we get a decimal that's less than 1 but greater than 0. So B is less than 1 but greater than 0. So it's a fraction or a decimal, so we know that's going to be decay. The same with this one, we have a fraction. So a fraction is less than 1 but greater than 0, so that's decay. And this one is a decimal, but it's a decimal that's bigger than 1. So although it is a decimal, it is still growth because it is a positive number greater than 1. Okay, so let's look at some examples. Here we have a painting with an original amount of 2,500. So it's giving us the starting amount, or the starting value, and it is increasing, so we know it's growth, by 5% each year. And we want to first write an equation that models the value of the painting. So remember, all models are a starting amount, a common ratio, multiplied by a certain number of times. So the starting amount, I'm going to say V for value. The starting amount is 2,500. The common ratio, the increase is given as a percent. So no change in value would be 100%. If you have an item that's worth 100% of what it was valued at last year, it's the same amount. And then if it's increasing, we're going to add 5%. So next year it would be worth 105%, and we're going to write that as a decimal. So remember, if you want to change something to a decimal, you're going to divide by 100. So that would give me my common ratio of 1.05. So 100% is the original amount, plus 5% because it's increasing, which is 105%, and then as a decimal would be 1.05. And a certain number of times, I'm just going to use T for time. So V is the value, and T is the time in years. You can still use Y and X if you want. I just like to use letters that represent what the situation is. So once I have that equation, then I can find the value of the painting in 3 years. So T is 3. So remember, order of operations, you want to do your exponent first. So we'll do 1.05 first. to the power 3, and then we will multiply by 2,500. So that gives me an end amount of $2,894.06. Okay, in this question you have a car that has a starting amount of $47,000. It is depreciating, so depreciate, that word means decreases. It's going down in value. So every time you buy a new car, it will go down in value every year at a rate of 20%. So again, we want to write an equation that models the value of the car. So value, I'm going to do V for value. The starting value of the car is 47,000. Again, we have a percent, so we're going to start with 100. 100% means no change. This time I'm decreasing by 20. So next year the car would be worth 80% of what it was originally worth. And then I'm going to divide by 100 to get a decimal. So my common ratio would be 0.80. And I'll do T for time in years. And then now that I have the equation, it wants me to find the value of the car in 6 years. So we'll do 0.80 to the power 6. So again, we want to do our exponent first. So 0.8 to the power 6 first, and then multiply it by the original amount of 47,000. So now it's worth $12,320.77. So we can see after 6 years it's gone down in value to 12,000. Okay, here's a few questions that we can try. So the first one is a population. We have the original population, and we know it is increasing by a rate of 2%. So we want to write an equation and then determine the population in 5 years. So I'm going to use P for population. The original population is 510,000 people. It's increasing by 2%. So starting with 100, it's going up by 2%. So next year it'll be worth 102%, as a decimal would be 1.02. So that's my common ratio. And I'm going to do T for time in years. And then part B, we want to find the population in 5 years. So we'll just do 1.02 to the power of 5 and type that into the calculator. So we've got 1.02 to the power of 5, and then multiply that by the original population of 510. And the new population is 563,081. I'm going to round to the nearest person. We can't have a decimal of a person, so I'll just round to the nearest whole number. Okay, question 2. We have an original car that is valued at $2,400. So that's my original value. It is depreciating by 5%, so it's going down by 5%. So the original 100% is decreasing by 5. So next year it's worth 95%, or as a decimal, 0.95. And T will be my time in years. And then part B, it wants me to find the value in 7 years. So we'll do 0.95 to the power 7 first. And then we'll multiply that by the original value of the car, which is 24,000. So now the car is valued at $16,760.10. All right, moving on. Question 3. Every time Pinocchio lies, his nose grows about 10% of its original size. So it's increasing by 10%. The original length was 2 inches. So we want to write a model to, or an equation to model this. So what am I going to use for my, I'm just going to use y this time. So the original length of the nose was, well, let's use L for length. So L for length, the original length was 2. It's increasing by 10%. So we're going to add 10% to 100. So now it's worth, or the length is 110%. As a decimal, that would be 1.10. And then T will be the number of lies. So B, I want to find the length after 8 lies. So I'm going to do original length of 2, increasing by 10%, 8 times. So let's see how long his nose gets. So 1.10 to the power 8 times the original length of 2. So now his nose is going to be 4.29 inches long. And then the last question, we have Olaf drinking a can of pop that contains 120 milligrams, so that's the original amount. The amount of caffeine decreases by 12%. So I'm going to use A for amount of caffeine. The original amount was 120. It was 100% to start. It's going down by 12%. So 100 minus 12 is 88%, or as a decimal, 0.88. So that's my common ratio. And T will be my time in hours. And then it wants to know in 4 hours how much caffeine will he have in his system. So we'll put in 4 hours for time. And let's see how much caffeine is left. The power of 4 times 120 is 71.96 milligrams. Okay, I'm just going to do an extra part to this question. What if we wanted to know how long it would take to have, let's say, 50 milligrams in his system? So this time I want to figure out the time. So let's write the original equation. So the original amount was 120 and it's reducing by 88%. So this time I want to know how long it would take to end up with 50. So we want to solve for T. You can't multiply the 120 by the 0.88 because the 0.88 is not really 0.88. It's 0.88 to the power T, and we don't know what T is. So we really don't know this value. So we want to get rid of the 120. Since it is multiplied by the 0.88, we're going to divide, and we'll do the same on the other side. So we're going to get a decimal. So we've got 50 divided by 120 is 0.4167. Now, to solve for T, we're going to have to estimate. Okay, if you were in grade 12 advanced functions, you would use logarithms, which are the inverse of exponential, but we're not going to do that. We're just going to guess. So the question is 0.88 to what power is going to give us this number? So I'm just going to work my way up and try different numbers. So 0.88 to power 1 is 0.88. Then I'm going to try to the power 2. And I want to get as close as I can to this number here, 0.4167. So to the power 2 is 0.7744, which is a bit too big. So let's try to the power 3. And we get a little bit smaller, 0.6815. So let's try to the power 4. We're just going to work our way up till we get close to this number. So now we're at 0.5996. So I'm going to try 0.88 to the power 5. And that gives me, so I'm getting close, 0.5277. Let's try to the power 6. Okay, now we're in the fours, 0.4644. So I'll do 0.8 to the power 7. And I get a little bit smaller, 0.4087. So I know it's in between these two numbers. So if you want, you can go even more accurate. I might say, well, let's do 0.88 to the power of 6.5, because that's in between 6 and 7. So I can get as close as I want. Oops. And that works out to be 0.4356, which is a little bit too big. So I might do, let's do 0.68. And that's pretty close. So 0.4193. So I'm going to say that's pretty close. So I would say it's approximately 6.8 hours from my estimation. So you can estimate by just trying the base with different numbers to see how close you can get to this value. And another way to estimate is, well, I know it's 120. And I know it's going to reduce in half every 4 hours. So after 4 hours, oops, that's not how you spell hours. So after 4 hours, it would be down to 60 milligrams. Okay, so I know it's going to take at least 4 hours because I have to get down to 50. So after another 4 hours, it would be down to 30. So I know it's got to be between 4 and 8 hours, right? This is 4, this is 8. So I know it's got to be bigger than 4, less than 8. So then I might try 6. So you can approximate first and then just try different numbers. So if you have to find the exponent, you would have to estimate to find that answer.